Hi, let's learn how subnetting actually works. By the end of this, you'll be able to take any IP address with a slash number after it and work out everything about it by hand, with no calculator. We'll use the same example the whole way through. 192.168.1.130/26. An IP address is 4 numbers separated by dots. Each number is called an octet, and each octet is 8 bits, so it holds a value from 0 to 255. 4 octets times 8 bits each gives 32 bits in total. The dots are only there to help us read it. Your computer just sees one long row of 32 ones and zeros. It helps to know what kind of network you're looking at, and the first octet tells you. 1 to 126 is Class A. Only a few of these exist, and each one is enormous. 1 to 28 to 1 to 91 is Class B, sized for universities and big companies. 1 to 92 to 223 is Class C, the small networks you find in offices and homes. Class D is multicast, and Class E is reserved for experiments. 127 is missing because it's loopback, the address your computer uses to talk to itself. Our example starts with 1 to 92, so it's Class C. But the /26 we wrote always beats that old default. Some ranges have special jobs. Public addresses are unique on the whole internet, and your provider hands them out. Private addresses, the ones starting 10, 172.16, and 192.168, are free to use inside your own network. Millions of homes reuse the very same ones, so your router has to translate them on the way out. That's called NAT. 127.0.0.1 is loopback, and it never leaves your machine. And a 169.254 address is what a device gives itself when no DHCP server answers, which usually means something is broken. There are also 3 ways to send something: unicast to one machine, broadcast to everyone in the subnet, and multicast to a group. Our example sits inside 192.168, so it is a private address. Now, the only real skill you need, turning a number into binary. Every bit in an octet has a fixed value: 1 to 28, 64, 32, 16, 8, 4, 2, and 1. Go from left to right and ask one question. Does it fit? Take 130. Does 1 to 28 fit into 130? Yes, so write a 1, and we have 2 left over. 64? No. 32? No. 16, 8, and 4? No, no, and no. Does 2 fit into 2? Yes. Write a 1, and nothing is left. Everything else stays a 0. So 130 in binary is 10000010. Now, the mask. /26 simply means 26 ones, and then zeros for the rest. The mask is 32 bits long, exactly like the address. The ones mark the part that identifies the network, and that part is frozen. Every device in this subnet shares it. The zeros mark the host part, which is free to change. Written out in decimal, those 26 ones come to 255.255.255.192, because 11000000 is 128 plus 64, which is 192. To find which network an address belongs to, you apply the mask using an operation called bitwise AND. Line the 2 numbers up and work down column by column. A bit survives only if both bits above it are 1. Anything else becomes 0. The first 3 octets of our mask are all 1s, so 192.168.1 is copied straight through. Only the last octet needs work. 130 is 10000010. The mask, 192, is 11000000. Only the very first column has a 1 in both rows, so the answer is 10000000, which is 128. And there it is. The network address is 192.168.1.128. So how big is this subnet? Only the host bits can change, so they decide the size. There are 32 bits in total, and 26 of them belong to the network, so 32 minus 26 leaves 6 host bits. 6 bits can count 2 to the power of 6, which is 64. So this block holds 64 addresses. but 2 of them are already spoken for. The first one names the network itself, and the last one is the broadcast address. That leaves 62 addresses for real computers. Now, the 4 addresses you always get asked for. Keep the 26 network bits frozen, and just turn the 6 host bits all the way down and then all the way up. All zeros gives you 192.168.1.128. That's the network address, the name of the subnet itself. Add 1, and 129 is your first usable host. All ones gives you 191. That's the broadcast address, which reaches every device in the subnet at once. One below it, 190, is your last usable host. So the whole block runs from 128 to 191, with 62 usable addresses in the middle. Once you trust the binary, there's a much faster way. Take 256 and subtract the last number of the mask. 256 minus 192 is 64. That is your block size. Subnets always start at multiples of the block size, so here they begin at 0, 64, 128, and 192. Which one does 130 land in? It sits between 128 and 191. So the network is 128, and the broadcast is 128 plus 64 minus 1, which is 191. Same answers in about 5 seconds. It's worth memorizing these. /25 is 128, /26 is 192, /27 is 224, and /28 is 240. And that's the whole thing. The mask is 255.255.255.192. The network is .128. The first host is .129. The last host is .190. The broadcast is .191, and there are 62 usable addresses. 4 steps every single time. Write the mask in binary, and it with the address. Count the host bits, and remember, all zeros is the network, all ones is the broadcast. Now pause here and try one yourself. 10.0.5.77/28. Good luck.